So I will take the same example as given in lead code, the same grid given here 131, 151, 421. And let's start solving this problem using bottom-up dynamic programming approach. So we have got this grid, and now we have this is our start position to the bottom, right? This is our finish position, and we have to find the minimum path sum for whatever the paths are possible from start to finish. So there are various ways possible, right? So as given in the problem statement, we can only move right from here or move down. So if I try to start solving this problem, so if I move say right, if I move right here, in that case, our problem is now divided into a sub problem, right? Now we have to see that what is the minimum path sum from this to the finish point. Or in other words, we are just going to take this portion of grid to find the minimum path sum. And suppose we don't take this right path, but we go down. In that case also, we are reducing our grid to only this part, because there are only like two paths possible, either right or down, and we have to choose minimum of it. So it means that there would be either of these paths, right? Either he goes right, it can lead me to the minimum path sum, or it would be the down one, which is this sub problem or a sub grid, which will give me the minimum path sum starting from here. And once I get, so suppose for example, for if I go right and I get a path sum of minimum path sum of say 12, just give an example. And suppose for if from this position I go to down, and for this particular grid subgrid, I would say I get a path of say 10. In that case, we know that we have to choose this 10, right? Because 10 is less than 12. We have to find the minimum path sum. So 10 is less than 12, which means that we will discard this right one and we'll choose this down one, right? We are going to choose the down one, and then whatever the cost of this particular grid cell is there, so I will add one to it, because one is the cost of this particular grid cell as well. So it would be 10 plus 1, the total cost, right? So 10 plus 1 would be the total cost, just taking the random numbers. I mean, for 12 and 10 for two sub problems that we have divided. And we have to add 1, the cost of this grid, plus the minimum cost, which we have got either from right or from down, going down. So we have seen that we can divide this main problem into sub problems by moving to right or down. So this is like first condition, where we can see that this is similar to like solving a dynamic programming problem, where we can divide the main problem into a sub problem. Also, we can see that suppose I move right here, right? If I move right here, then I calculate the grid, the minimum path sum for this grid. And then suppose again going further, I go down here to find the minimum path sum from this 5 to 1, right? So 5 has been calculated here if I go right, okay? And suppose if I just go down from here, okay? I go down and then we are reduced to this grid. And from 1, I try to go 5 and 4, right? We can go right or down. So if I go from 1 to right, again, it will be subdivided into this grid. We have to find the minimum path sum for this small grid. So it means that either we move from 3 or either we move to 1 and then further subdivide the problems. This problem 5, this 5 grid is getting overlapped. It has been calculated for this 3 grid as well as for 1 grid. It means that our problems are also overlapping. And if we go just through this recursive approach, it would be a very exponential type of problem and it would not be efficient. So we have to think of a way that we can avoid this by using this dynamic programming approach, where we can reuse whatever we have already calculated. And whenever we see that in the cache, we just reuse that value. So these are the basics of the dynamic program, as we have been learning from the last 19 problems that we have solved. So same goes with this problem as well. We have to find, we are able to divide this problem into sub-problem first. Second, we should be able to reuse the results of the sub-problem that we have already reduced. So again, going back to this first condition, that if I move from 1 to 3, and suppose the minimum cost of this is say 12, right? And similarly, if I go to this path and then I just choose this subgrid and get the sum of 10. So it means that the formula, we are seeing a pattern or a formula here, that we have to choose the minimum of these two, say 12 and 10, the minimum is 10. Then we add 1, which is the cost of this cell, and which will give me the final solution for this minimum path for this particular cell. Now we can expand this idea to all the cells here. So I can write this formula for a particular, if I call this particular cell as dpij, I mean, if I'm taking this as dp of 0, 0, then this formula, as we have calculated here, is 10 plus 1, right? 10 plus 1 means 1 is the cost of this cell itself. So it would be grid. I'm just taking the grid as the cost of this cell. The grid ij, it corresponds to 1. And then plus minimum of the 12 and 10, right? 12 is one where I mean the minimum pass sum from this right cell to the bottom, and 10 is the minimum pass sum from 1, which is going from 1 to down, from 1 to the finish. So this can be again written as the same formula. Guys, just note this, and these are the arbitrary numbers. We haven't calculated it yet. So I'm just giving the example. Okay. So it would be dp of I plus 1, or I would just say I. So I'm taking j plus 1. J plus 1 is this cell, right? And similarly, minimum of this, or dp of the bottom one. Bottom one is I plus 1 j. So this is the formula. Again, grid I mean dp of this particular cell would be the cost of this cell. Cost of this cell is 1, which is grid of ij, plus minimum of going to the right. That is a minimum from dp I j plus 1. J plus 1 is column plus 1, which is this for this cell, and dp of I plus 1 j. I plus 1 is the next row and the same column, which is 1. So this is our main formula. Now let's try to calculate for all these cells, and then we'll go from the bottom up approach, which means that we'll start from the bottom one and we'll use the same formula to calculate dp of ij for each cell, and then we move up, and this will give me the final solution.